Good morning, children. It is I, Mr. E, ready to give you some information on exponential growth and decay. This is good stuff, so let's get right to it. Here we go, exponential growth and decay. All right, exponential growth is a function that's in this form right here. See where x is the exponent now. And this value here, b, is greater than 1, and it's actually this value right here, which is the rate, and then we'll show you what that means here. Y, it's y right here. This is your final amount. That's what you're looking for. A is your initial amount, the starting amount, what you start with. 1 plus R, that's the rate of growth. And then T, that's time. So here's an example of what I mean. Population of a city is increasing at a rate of 4% each year. So here's your rate of 4%. And in 2000, there were 236,000 people in the city. Here's your starting amount. We want to write an exponential growth function to model this situation. Then find the population in 2009. Well, we started in 2000 and we go into 2009, so this is going to be 9 years. It's going to be 9 years. Alrighty, so step 1, identify the variables. Well, we just did the rate equals 4%, and we're going to write it in decimal form, 0.04. All right, and then the initial amount, A, the starting amount, was 236,000. And then the time is 9 years. Okay, we're going to substitute for A and R and then simplify. So I'm going to do all this in orange here. Substitute for A and R and simplify. Okay, so we're going to write Y equals, now A was 236,000. And then the rate is 1 plus R, which is 0.04. And then T, well, that was 9. There we go. Yes, we've done that already. Okay, so substitute for A and R and simplify. What we're going to do here is we're going to simplify inside the parentheses there. So let's rewrite this. We found T by subtracting the years, so we did that already. Find T by subtracting the years. We did that over here. There it is again right there. Substitute for T and solve for Y. Well, let's simplify. So Y equals 236,000. 1 plus 0.04 is 1.04. That's not right. And then there's 9. So now we're going to solve for Y. And all we're going to do is plug that into our calculator. 236,000. Plug it in my calculator now. 236,000 times 1.04. Put that in parentheses. 1.04, close parentheses, and then raise it to the 9th power. And that gives us this amount. Y equals 335,901. And we could even round it up if you wanted to 0.6, but can you have 0.6 people? No, so we're just going to put this, 335,901. So after 9 years, at a population rate growth of 4% each year. After 9 years, there was 335,901 people. So that's how that works. Now let's look at a decay. Now this is pretty much the same thing, except for now uh, b is less than 1, but greater than 0. So it's a fraction. And r is the rate of decay, again. So here, y is the final amount. That's this right here, final amount. A is still your initial amount, right here. Y is the final amount. The rate of decay now is 1 minus r. That's what makes it a fraction. And then t is your time right there. Okay, so now we have a city. The population is decreasing at a rate of 6% each year. So there is the rate. Where's my pen? Hello. Okay, I seem to be frozen. All right, what's going on here? I need to pause. Okay. Everything has frozen. Wonderful. Oh, there it is. Wow. Okay. Let me undo. I don't know what's going on, but I just wrote all of this. Okay. Well, we're back. Sorry for that pause. Let's get back to it here. Rate of decay. Here we go. Green. Rate of decay. Rate of 6%. There's a decay. And in 2000, there were 35,000 people in the city, so that is the initial amount. And then the time, we can do that again. 2000 to 12, let's see, that was 12 years. So that's going to be the time. So we're going to identify the variables. We've done that. Let's see, the rate is 6%. And remember that in decimal form is 0.06. And then the initial amount, that was A, that's 35,000. And then the time, well, we can put it down here. Time equals 2,000. Well, 2012 minus 2,000 equals 12. So T is 12. Let's go ahead and plug that in. So Y equals, A was 35,000. And then the rate, that's 1 minus 0.06. And then T, we found that already. We can put it right here, 12 years. Okay, we're going to substitute for T and solve for Y. So here's our equation right there. Let's go ahead and solve it. We'll just plug it into the calculator. But we can simplify it just a little bit. 35,000. 1 minus 0.06 is 0.94. So you see how we're, on the first one it went up here. It's 101.04, so it's going up, and now it's 0.94, so we're multiplying by less than 1. So it's going to be going down, and that's 12. So that equals, type that into your calculator just as it appears with the parentheses and everything, 0.94 raised to the 12th power, and that is 657 people. There we go. All right, so now we're just going to write the function for each situation. So let's see if we can do that. I'm sure we can. Let's see. Annual sales at a company are $372,000 and increasing at a rate of 5% per year. So there's your rate. That's R. And this value here, annual sales, are this and increasing. So it's going to start at that. So there's that. So let's write that equation. This is Y equals A, which is the initial amount, times 1 plus the rate, because it's increasing, so 1 plus 0.05 per year, t. So we just, what will be the value in 8 years? Oh, that's the next question. What will be the value in 8 years? That's going to be our t value. So we just plug 8 in for t. Y equals 372,000. 1 plus 0.05 is 1.05. And then raised to the 8th power. So we'll just plug that into the calculator. 372,000. Parentheses 1.05. Close parentheses. Raised to the 8th power. That is this amount, $549,613.43. There we go. All right, let's try this one over here. Let's see. Monthly car sales for a certain type of car are $350,000. So that is our A value. They start at this. That's A. And are decreasing at a rate of 3% per month. So decreasing, that's going to be going down. So this is decay. So this is going to be Y equals 350,000. And then the rate is 1 minus 0.03 raised to whatever time. And they want the value in 6 months. So we're going to plug that into our equation and get that value. So Y equals 350,000. 1 minus 0.03 is 0.97, and then raised to the 6th power. So plug that into your calculator just as it's shown there. 350,000, parentheses, 0.97, close parentheses, raised to the 6th power. That is this amount. The value is 291,540.20. So that's the value in 6 months. Okay. Well, there's a couple of examples. Let's see what we have next. Okay. Internet chat room has 1,200 participants and is decreasing at a rate of 2% per year. I think we can do that. Let's see. We start here, and that's the rate. And it's decreasing, so it's going to be 1,200 is the initial amount. 1 minus 0.02 to the t. So we plug this in, 1,200. 1 minus 0.02 is 0.98. And t is 5. So that's going to be 1,200. Open parentheses, 0.98. Close parentheses. Raised to the 5th. That is 1,085. We'll round it up. Okay. Let's try this one. The population in town is 4,200 and increasing at this rate. So the starting amount is 4,200. It's increasing, so it's 1 plus 0.03 to the t power. So if t is 7, here we go. 4,200, 1.03. We add those together and then raise to the 7. So plug that into your calculator. 4,200, parentheses, 1.03, close parentheses, raised to the 7th. And that is 5,165. Okay, so you see, this isn't too difficult. We're just plugging stuff in to an equation, just like we did with the quadratic formula, except for this doesn't have near as many things. And the only thing to remember is this increasing or decreasing. If it's increasing, it's 1 plus. If it's decreasing, it's 1 minus. That makes sense. Okay, so given the following exponential function, identify whether the change represents growth or decay, and determine the percentage rate of increase or decrease. Okay, well, let's see. We just want to know if it's growth or decay. And we do that by looking at this value here. Remember the B value, that's your rate. And if B is less than 1, then it's decay. And if B is greater than 1, then it's growth. That's pretty easy. So this is less than 1. So it's a decay. And the way we figure that out is we find the difference between 1 and that. So 100.98. Subtract that, that's 0.02. So there's our, and remember this becomes percent, 2%. You move that decimal over 2 places. So this is a 2% decrease. Okay, how about the next one? What is this? This is greater than 1. So we just subtract 1 from that. 1.75, that's 0.75. And this is 75% increase. And some of this you can probably do in your head. Let's see, that's less than 1. This is less than 1. So this is and you can move that over there, 75%. And it's a decrease because it's less than 1. Let's look at these two. But these last two. Is this growth or decay? That is decay because it's going down. Let's see, that is, what's that, 43? So that's 43%. 43% decrease. And this last one, we have it's up there on the next page. This last one, well, this is greater than, the B value, B is greater than 1. So 1.03. I'm sorry. 1.00, 1.03. The difference is 0.3. So that's 3%. And that's a 3% growth. Or increase is what they had. A 3% increase. And that's growth. This last one is decay. Decay. Growth. Forgot to circle those. And that's decay. Okay, easy. If this number here is bigger than 1, it's growth. If that number there is less than 1, then it's decay. Easy, easy stuff. Okay, that's it for today. You can go and do the Delta Math assignment. It's probably just as easy as this. So there you go. I'll see you next time.